In this video, I will guide you through a problem in Smith's Organic Chemistry. I'm Stoddard, founder of Study Chem, the place for students to turn for higher grades in OChem. Let's get started. Alright, here we've got some chemical names, and we're asked to draw the structure. When you're doing these problems, you work backwards. So we first look at the 7,7-dimethyl octan 4-ol, and we first start drawing out an octane skeleton. So and you can just draw it linearly here, and let's go ahead and just number the carbons to be clear on where things might go. And you can see how I accidentally made 9 carbons. So let's erase the last one. That's another purpose for numbering the carbons. And then we just stick things on where they're indicated. So there's an alcohol at carbon 4. So let's put an OH here. There are 2 methyl groups located at carbon 7. So I'll put one line coming here and one line coming there. So you can see how it's pretty easy to draw a structure given the IUPAC name. For part B, we have, look at the very end, heptane. Heptane is 7 carbons. So let's write this out. 1, 2, 3, 4, 5, 6, 7. All right. 1, 2, 3 is going to be where my alcohol is. Carbon 4 right here is going to be where a propyl group is, and carbon 5 is going to be a methyl group. Okay. So carbon 1, 2, 3, here's my alcohol. Carbon 4 is a propyl. It doesn't say isopropyl, it just says propyl, so that's 3 carbons. Okay, 1, 2, 3, 3 carbons. Make sure there are 3 there. Carbon 5 has a methyl group, so we'll draw just a line coming down from there. All right, so that's how you do part B. Now for part C, we have cyclohexane. Okay, cyclohexane. So for part C, we start off by drawing a hexagon. You notice how there's no number here for the alcohol. The alcohol is always assumed to be carbon 1. You can put it creatively wherever you want. I generally put it at the 12 o'clock position. Okay, let's go ahead and number the carbons here. So carbon 1 is always assumed to be where the alcohol is when you have a cyclic alcohol. Okay, 4, 5, and 6. So there's our 6-membered ring. We have a methyl group on carbon 3, so that comes off here. We have a tert-butyl group coming off of carbon 2. So here's carbon 2. A tert-butyl group has 3 methyl groups sprouting off of a carbon. Okay, so that's the tert-butyl group. So that's how you do part C here. Now for part D, we have trans-cyclohexane 1,2-diol. So let's start off with cyclohexane. Okay, and we want to number the carbons here again, and like I said, I kind of just put the carbon 1 up on the top. No need to number the rest. We have 2 groups attached to carbons 1 and 2. They're alcohols. And so the alcohols are trans, so that means 1 up, 1 down. So we use a wedge to show one of the alcohols and a dash to the other alcohol. Now here we actually have numberings for the alcohol even though we have a ring, because we have 2 functional groups. We have an alcohol functional group at carbon 1, we have an alcohol functional group at carbon 2. So to indicate where those are, we have to use 2 numbers. Okay, that's the way IUPAC decided to do it. So trans means 1 wedge, 1 dash for 6-membered rings. So that's how you do part D here. Thanks for watching.